Now we are going to discuss about software defined radio. What is the meaning of software defined radio? Software defined radio is defined as radio in which some or all of the physical layer functions are software defined. Some or all physical layer function, most of the physical layer functions are software defined, that is called software defined radio. Introduction of software defined radio. In this world, the data community networks plays a vital role in any modern society. They are used extensively in numerous applications, including financial transactions, social interactions, education, national security, and commerce. With the exponential growth in the ways and means by which people need to communicate, data communications, voice communications, video communications, broadcast messaging, command and control communications, emergency response communications, etc. So in this world, that data communication, nowadays the data communication is the main role, that plays the main role in the society. Now, the modification of radio devices easily and cost effectively has become business. So, this is the introduction. Next, we are going to discuss about the software defined radios. Software defined radio is the software discovered before cognitive radio. Okay, that is the software discovered before cognitive radio. The basic concept of the SDR software radio is that the radio can be totally configured or defined by the software. Okay, the radio can be totally configured or defined by the software. Totally it is defined by the software. So that a common platform can be used across a number of areas. Okay, the software SDR radio, that is totally configured by software. So the common platform can be used across a number of areas. There is also the possibilities that it can be reconfigured as upgrades to standards array, or if it is required to meet another role, or if the scope of its operation is changed. Do you know what is software? Everyone already know. Software is the part of a computer system that consists of encoded information or computer instructions in the contrast to the physical hardware from which the system is built. So software means what? Software means it is a part of computer system that consists of computer instructions. Okay, that is the computer system. So it consists of software instructions. Next, what is radio? Radio is the technology of using waves to carry information such as sound by systematically modulating some property of electromagnetic waves transmitted through space, such as their amplitude, frequency, phase or pulse width. Okay, radio is the using waves to carry information that can be sound that is transmitted through space. We know radio means that is that carry the information and it transmit the information through the space. Now let's see why software meets radio. There are drawbacks with pure radio systems. So software needs to incorporated with hardware radios. Okay. If you are using pure radio hardware system means there are some drawbacks. That is less flexible, high design cost, difficult to update new technologies. Okay, these are the drawbacks of radio system without software. So what are the drawbacks? That is less flexible, high design cost, difficult to update new technologies. Definition of software defined radio. Number of definitions can be found to describe software defined radio. We know software defined radio, the short form of software defined radio is SDR. The SDR forum working is collaboration with the Institute of Electrical and Electronic Engineers group has worked to establish a definition of SDR that provides consistency of a clear overview of the technology and its associated benefits. The definition is the radio in which some or all physical layer functions are software defined. When all or some of the physical layer functions of a radio are defined in software, it is called software defined radio. Okay, clearly understood? When all or some of the physical layer functions of radio are defined in software, it is called software defined radio. A software defined radio is a radio system where the majority of baseband processing, that means physical layer functions, are done in software, which includes modulation, forward error correction, spreading, filtering, frequency, timing synchronization, and so on. Next, we discuss about the applications of software defined radio. One applications may be for cellular base stations where standard upgrades frequently occur. By having a generic hardware platform, upgrades in standards can easily be incorporated. Any evaluation can be easily deployed just by upgrading the software. For example, UMTS to HSPA and on to LTE could be accommodated simply by uploading new software and reconfiguring it without any hardware changes, despite the fact that different modulation schemes and frequencies may be used. So next, ideal SDR architecture. The ideal software radio consists of a wideband antenna, wideband ADC and DAC, that is wideband analog to digital converter and digital to analog converter. The concept of SDR, that is shown in figure, the conversion process between the analog and digital signaling domains be carried out by digital to analog converter and analog to digital converter. So this is the ideal SDR. So here the conversion process between analog and digital signaling domain were carried out the ADC and DAC. The ideal SDR architecture is more flexible such that the radio may be configured occasionally in real time to adapt to various air standards and waveforms, frequency bands, bandwidth and modes of operation. That is, the SDR is a multifunctional, programmable and easily to upgrade radio that can support a variety of services and standards while at the same time provide a low cost, power efficient solution. Working of ideal SDR. So SDR means, that is software defined radio. The received signal comes from an antenna. That is the form of analog. We know the received signal, antenna receive the signals that is in the analog form. That analog signal is converted into digital signal by using analog to digital converter. Remaining processing is done in software. So ideal SDR, there are two hardware components are used. One is antenna, another one is analog to and digital converter, digital to analog converter. Both are hardware. Remaining all processes are done by software. Okay, so SDR mostly some or all physical layer functions are software defined, but here antenna and converters, ADC, DAC converters are hardware. Rest of the signals processing that is done by software. The transmitters performs all the signal processing in software, but the sending of signal out of antenna is done by digital to analog converter. So these are the limitations of ideal SDR. The requirements of the ADC and DAC varies between applications. There will be software compatibility issues in different types of hardware implementation. That means the requirements of ADC and DAC as dictated by dynamic range, sampling rates and bandwidth specifications for exceed practical capabilities. Also, they vary along with the applications. There will be software compatibility issue in different types of hardware implementation. There are different types of hardware implemented based on applications such as field programmable gate array, digital signal processor, general purpose processor, which creates the compatibility issue with the software used. Potential benefits of SDR. The usage of software-defined radio various advantages over the hardware radios. Few of the advantages are mentioned below. That is, SDR offers the greatest flexibility. SDR provides software reusability. Testing and analysis made easy using SDR. So first benefit, that is SDR offer the greatest flexibility. Developing and debugging software is much easier and more potential and more cost effective than designing and producing hardware. We know normally producing hardware software will be very easy. So here developing and debugging is very easy and this is more cost effective than designing and producing hardware like an ASIC where the turnaround time is long and expensive. Okay, if you are design ASIC that is the hardware. If you are designing ASIC means it will take more time, maybe 8 weeks. It will take 8 weeks. But this SDR, that is mostly software defined, so that developing and debugging is very easy. Then SDR offers easy upgrades and bug fixes in developing systems. Okay, if a new system or waveform is required, as long as there is enough processor power, software updates can be pushed to an existing operating system. This capability saved time and cost of design and deployment, and it lowered the cost to the service provider who do not have to install a new system. So the first benefit is SDR offer the greatest flexibility, that is saving time and cost of design and deployment. Okay, saving time and cost of design and deployment, and it lowered cost to the service provider who do not have to install a new system. Second one, SDR provides software reusability. When software is modular and well written, it can be ported between processor with minimal rewriting. Okay, when software is modular and well written, it can be ported between the processor and minimal rewriting. This is not suitable for FPGA based SDR system where the software language is too low level and does not provide sufficient abstractions to be platform independent. Nevertheless, in systems that the GPP based code portability is a major advantage. So SDR provides software reusability. When software is modular and well written, it can be ported between processor with minimal rewriting. Next, testing and analysis made easy using SDR. It is easy to test individual signal processing blocks, simulate performance and test behavior in a closed system, and then reuse the same software for a real over-the-air system. Next, we can see the function of SDR. So SDR receives the signal from the antenna. You know, radio waves that is received by antenna and transmit the information using the antenna. So here the SDR receives the signal from the antenna that is in the analog form. That analog signal is converted into digital signal by using analog to digital converter. At the receiver side, digital signal that is converted into analog signal. After that, it is transmitted through the antenna. So here that is smart antenna. So here this section is transmitting antenna and receiving antenna. This is intermediate frequency. This is analog to digital conversion and digital to analog conversion. This is front end. Then this is the software section, that is baseband processing. So RF front end, that RF, this is the RF front end. This is responsible for transmitting and receiving radio signal from the antenna and converting them into an intermediate frequency. So this RF front end uses that is responsible for transmitting and receiving radio signal from the antenna and converting them into an intermediate frequency. What is the reason for intermediate frequency? Means why we are converting into intermediate frequency means to improve the frequency selectivity. So improve the frequency selectivity, we have to convert the signal into intermediate frequency. So next this in this section that is used analog to digital up converter and digital down converter in this channelization and sample rate conversion. So digital up converter means it convert the complex digital baseband signal to the passband signal. Then digital down converter, it is the counterpart component to digital up converter. Okay, counterpart component of digital up converter, and it is an equally important in the communication systems. Its function is to translate a passband signal comprising one or more radio or intermediate frequency carries to one or more baseband channels for demodulation. So here the baseband signal is, we know that is the original transmission signal. So original baseband signal should be modulated to higher frequency of radio transmission. The original baseband or low pass signal are converted during the transmission process. When the signal arrives at the destination it is demodulated. Okay, original signal, that means the low pass filter are converted during the transmission process. It is converted. When the signal arrive at the destination, it is demodulated so that the recipient receives the original baseband signal. Next is baseband section. This is the baseband section, so which performs operations such as connection setup, equalization, frequency hopping, coding, decoding, and correction, while also implementing the link layer protocol. So this is the features of software defined radio. Next, goal of SDR. What is the goal of software defined radio? Software defined radio perform significant amount of signal processing in a general purpose computer or a reconfigurable piece of digital electronics. The goal of this design is to produce a radio that can receive and transmit a new form of radio protocol just by running new software. By running new software, this SDR design can produce a radio that can receive and transmit a new form of protocol. The ultimate goal of SDR is to provide a single radio transceiver capable of playing the roles of cordless telephone, cell phone, wireless fax, wireless email system, etc. What are the benefits we have to using SDR? Probably the largest benefits of SDR technology is the flexibility it offers. Okay, developing software to perform signal processing offers large opportunity for improving the development cycle. From an operations standpoint, developing and debugging software is much easier, practical, and cost effective over designing and producing hardware such as application specific integrated circuit, that means ASIC, where the turnaround time is long and expensive and a large barrier to entry into the field. From a service provider's perspective, software-defined radio offers easily service upgrades and bug fixes in developed systems. If a new system or waveform is required, as long as there is enough processor power, software updates and can be pushed to a system operating in the field. A successful example of this was the recent upgrade of WAN, that is mobile communication system, and were upgraded to support code division multiple access. Code division multiple access means VCDMA. This capability saved time and cost of design and deployment, as well as lowered the cost to the service provider who did not have to install a new system. Okay, although in this specific case, the SDR is done primarily in general purpose processor, many SDR platforms are being built around FPGAs, which can easily handle concepts like software upgrades when changes are infrequent. Okay, when changes are infrequent and do not require real-time adaptation of a waveform. While FPGAs offer significant performance and power changes to the FPGA that can take on the order of seconds, an acceptable lag when updating a system, but not quite for reconfiguration of a waveform in cognitive radio setting. Another benefit following these two items is the concept of reusability of software. Okay, so another benefit is that is the reusability concept of software. When written well with a concept of modular code, software can be ported between processor with minimal rewriting required. Here, unfortunately, this is not entirely the case in today's FPGA-based SDR systems, where the software language, generally high-speed integrated circuit, high-speed integrated circuit hardware description language is low level. Okay, here and generally that VHDL is low level and does not provide sufficient abstraction to be platform independent. We suspect this will change as more influence from the computer science community affects development practices in the SDR world. The systems that are GPP based, however, code portability is a major advantage. Another benefits of SDR is being software already, it is easy to test individual signal processing blocks. Okay, so if SDR is that software, once it was ready, so that is easy to test and it stimulates performance and test behavior in a closed system and then reuse the same software for a real overall system. So these are the benefits of using SDR. SDR means that we know that is software defined radio. So software defined radio, it has some of or all physical layers are software defined. That means here antenna and converters, ADC converter, DAC converters are only hardware. Remaining all the processor is done by the software. So only it is called software defined radio. Again, one more time I explain SDR. So normally radios are totally configured by hardware. Nowadays it is used by software. Why we are using software means there are many drawbacks is using in pure radio system. The drawbacks are less flexible, high design cost, and difficult to update new technologies. So software need to be incorporated with hardware radios. If we are using software means we can easily modify mm, compared to hardware radio. So software defined radio means that is some or all physical layer functions are software defined, that we know. Here a software defined radio is the radio system where the majority of baseband processing are done in software, which include modulation, forward error correction, spreading, filtering, frequency, timing, synchronization, and so on. One application may be for cellular base stations where standard upgrades frequently occur. By having a generic hardware platform, upgrades of standards can easily be incorporated. Any evaluation can be easily deployed just by upgrading the software. For example, UMTS to HSPA and on to LTE could be accommodated simply by uploading new software and reconfiguring it without any hardware changes. Despite the fact that different modulation scheme and frequencies may be used. So here, architecture that use antenna, A to D converter, D to A converter. A to D converter is used to analog to digital converter because the software antenna is receive the signal in analog form, but computer software know only the digital signal. So we have to convert the signal into signal analog from digital. So we are using ADC converter. At the end, antenna transmit the information by using the analog signal. So we have to again convert into at the receiver side, destination side, we have to convert digital to analog signal. So first in the antenna that receives the signal in analog form, and by converter, this converter and the antenna sessions of hardware in software defined radio, remaining processor are done by software. Remaining all the process is done by software. There are some limitations that you have in ideal SDR, that is the requirements of ADC and DAC varies between applications. That means the requirements of ADC and DAC are dictated by dynamic range, sampling rates, and bandwidth specification for exceed practical capabilities. Also, they vary along with the applications. Then there will be software compatibility issue in different types of hardware implementation. There are different types of hardware implemented based on the applications such as field programmable gate array, digital signal processor, general purpose processor, which creates the compatibility issue with the software used. There are some difficulties in implementation. In software defined radio, there are some difficulties. That is, bit rate means the rate at which the bit can be transmitted. It will take more time for sending the bits one by one in forward error correction. The decoding process is very complex at the receiver side. These are the drawbacks. Decoding process that is normally very complex at the receiver. The modulator converts bits into symbol in the complex plane for transmission, and receiving process requires computationally expensive frequency phase and timing synchronization to properly demodulate digital signal. Next, potential benefits of SDR. There are three potential benefits. That is, SDR offers the greatest flexibility. Flexibility means it is saving the time, and cost also very low. Then second one is SDR provides software reusability. When software is modular and well written, it can be ported between processor. Between the processor, it can be ported. Testing and analysis made easy using SDR. It is easy to test individual signal processing blocks. Okay, these are the benefits of SDR. That is, SDR offers the greatest flexibility. SDR provides software reusability. Then testing and analysis made easy using SDR. or a friend at the architecture or a friend end that transmitting and receiving the radio signal from the antenna and converting them into the intermediate frequency. So here that or a front end processor main function is that convert the signal into intermediate frequency. Why it convert the signal into intermediate frequency means to improve the frequency selectivity. If the frequency selectivity is better, the signal is sending at the destination very correct manner. Then digital up converter are used and digital down converter are used. Digital up converter is used to pass the baseband signal into passband signal, and down converter it is used in the destination side. So it is demodulate the baseband signal. It is used to demodulate the baseband signal. And baseband section, this is the software section in this SDR. So baseband section is the software section in the SDR which performs operations such as connection setup, equalization, frequency hopping, coding, decoding and correction, while also implementing the link layer protocol. Then finally goal of SDR is by running new software, this SDR design can produce a radio that can receive and transmit in new form of protocol. Then finally one more time I tell the benefits of SDR. It is possible to achieve very high level of performance. Okay, it is possible to achieve high level of performance, and performance can be changed by updating the software. It will not be possible to update hardware dependent attributes through. So the same hardware platform can be used for several different radios. Then it is possible to reconfigure radios by updating software. Software defined radio can talk and listen to multiple channels at the same time. So this is the benefits of SDR. In SDR, we can talk and listen multiple channels at the same time. So this is the explanation of SDR. Thank you.